All right, if you're still not getting these problems right, you're gonna want to, because they're not that difficult. It's not rocket science. So 5x squared minus 10 equals 0 is missing the linear term. So this quadratic, general quadratic, ax squared plus bx plus c equals some number. There's variety of ways of solving those equations, and we're always looking for the easiest. Well, there are two types of quadratics that answers are almost handed to you. So you want to recognize them and you want to get it right on your next test. So 5x squared minus 10 equals 0. Something minus 10 equals 0. 5x squared has to equal 10. There's no ands, ifs, or buts about it. Let me get my eraser. So hopefully that makes sense that subtraction of 10 becomes addition of 10 on the other side. I'll leave this term here for now, but later we're just going to boom, boom, boom our way down. So we have 5 times something equals 10. Well, it's got to be 2. So I hope that on some intuitive level tells you that multiplication by 5 is division by 5 on the right. And if you're squaring something and you want to get 2 as a result, then it's the square root of what you're looking for. And we've talked a lot about x squared as having positive and negative answers. And at some point, you have to remember to write the plus or minus. And for a problem like this, the only thing that gets a check is plus or minus root 2. So if you say root 2, no credit. I anticipate that you can get root 2. I'm looking to see if you remember about the plus and minus. All right, so that's one type. So let's do 4 more of those and let's just solve them quickly. I will do 5x squared plus 10 equals 0. That has a little bit of a kick to it. So that's minus 10, that's minus 2, that's plus or minus the square root of minus 2, and that's equal to plus minus the square root of 2i. I haven't been giving you that situation yet. A week from now, we'll be talking about imaginaries, and we will include that. And what's really happening here is we have, that's in graphing form, by the way, 5x minus 0 squared plus 10. So this is really a graphing form. So the vertex is at 0, 10. And if we want to find 0, that's here. Well, that's kind of like the same thing as finding a change to 20. This is a change to 10, but instead of going up 10, we're really coming down 10. And this x value is what gets that intersection, and this x gets that. It's just that we have to call this number something different because, well, we'll have that discussion in a week. So that would be your answer. I'm not giving you that type of problem yet, so you don't have to worry about it. I'm just going to give you things that have real solutions, at least what we call real solutions. To me, that's a real solution as well. Mathematicians, square roots and negatives are called imaginaries. On some level, I'm imagining the graph going in a different direction. So that lends itself a little bit to that nomenclature. But mathematicians nowadays really don't think it's a great name for that situation. It's a number that gets the job done, just like other numbers get the job done. All right, so let's just solve 3 more or 4 more of these. So let's do 4x squared minus 9x minus 9, sorry, equals 0. So bring the 9 over, divide by 4, take the plus minus square root of 9/4, which actually is plus minus 3/2. All right, let's do another one. Remember, we're doing ax squared plus c, a quadratic without the linear term. We got the quadratic term, the squared term, and a constant. So let's look at 3x squared minus 10 equals 0. Let's make it minus 11. We've already used the number 10. All right, so you bring in the 11 over, you're dividing by 3, and you're remembering plus minus square root of 11/3. And 2 more. Let's do minus 7x squared minus 20 equals 0. Let's solve it for something other than 0. Equals 7. I already used the number 7. I don't like using it twice. Equals 4. Okay, so what do we have? We have minus 7x squared equals, adding 20 to this is 24. I didn't want to do that, so let's make that a positive. Okay, so taking away 20 makes that negative 16. Dividing by a negative gets us x squared equals 16 over 7. And so solving that gets us, and I'll accept it this way, plus minus the square root of 16 over 7, which is also plus minus 2 over root 7. And I don't rationalize those anymore. Sorry, 4 over. All right, one more. And then I hope you don't skip it on your next test. Let's look at minus 6x squared minus 12x equals 40. All right, so minus 6x squared is going to equal, I said x, I'm sorry. And I don't want to give you that situation. So let's go 6x squared minus 12 equals 40. All right, sorry about that. Add 12, 52. I'm going to divide by 2 here. So 3x squared is equal to 26. All right, so now x squared equals, and I hope you start skipping steps here. I hope you just write the answer down in your head. Equals the square root of 26 over 3, and plus, yeah, I'm jumping ahead. So x squared equals 26 over 3, therefore x is equal to plus minus the square root of 26 over 3. We'll do one last one. I'll do a negative. I can't do a negative. It's got to be a positive with a minus. So let's look at 5x squared minus 17 equals 30. Yeah, that's a nice one. So that's 47. That's 47 over 5. That's plus minus the square root of 47 over 5. I hope that you can actually almost do that in your head. I wouldn't encourage you to, because you still might make a careless error, but hopefully you're doing that in 10 seconds. All right, and you can do these in 10 seconds too. One of the videos I put out was how important it is to work with zeros in terms of domain issues, in terms of solving inequalities. And it's in our arsenal for solving situations that equal 0. The ability to turn sums and differences into products. And I don't take the 5 out. I just take an x out, 5x minus 10. I like seeing it that way. And so one of my answers is always 0. And the other one you can see is 2. I'd see, it's not hard. It's not rocket science. Just take an x out. And one of the factors, right? If a times b equals 0, then either a is 0 or b is 0. Right? So that could be my a and that could be my b. Those are my factors. All right. So I can't make it any more difficult than that, other than saying 7x squared equals 15x. That's the only way I can make it a little harder. And you would have to then get your variables together. That's one of the first rules of solving any equation. You got to get your variables together. And now I've got a product equaling 0. If I take an x out, 7x minus 15 equals 0. So there's one x and then the other. All right, so that's our second one. We'll do 3 more, and I'll upload these videos and it'll be assigned for Tuesday. So let's look at 3x equals 9x squared. Maybe that's even harder. So I'll move the 3x to the other side. And I'll set 0 equal to x times 9x minus 3. That's a little harder, maybe. X1 is still 0. That's always the case. And this one over here is positive 3/9 or 1/3. Right? 2 inverse operations. Subtraction becomes addition. Multiplication becomes division. Okay, what else can I make it? Let's do minus 2x squared plus 53x is equal to 0. I'm going to set it to 0, obviously. So I'm going to take an x out. And that's minus 2x plus 53 equal to 0. So again, there's 0. This one over here is negative 53 divided by negative 2 is positive 53/2. We'll show you that if this is 0 and this is 0, 0 times 53 is 0. If this is 53 over 2 and this is minus 2 times 53 over 2. I hope you can see the 2's cancel. And I get minus 53 plus 53 is 0. And 0 times anything is indeed 0. The nice thing about this is, I know I got a cup shape down. And I got a 0 on the increasing side. So 0 gets me 0. So there's the origin. 53 over 2. It's a little bit bigger than 26, right? 26 and a half gets me a 0. Which means that 53 over 4 is the average of those. And I got the X value. So, you know, I'm a step away from finding the Y value, but I don't feel like working with the fractions right now. And I think we just did 5 of those. So if you were pausing the video and trying them, hopefully you benefited from them. And those questions will be on every test till December 15th. All right. See you in class.